All right, let's look at the homework 7.9, problem number 2. All right, so we want to set up the integral for both order of integration and pick the easier one to evaluate it. All right, so let's do that. So let's do the volume. All right, so the volume is equal to, so it's going to be a double integral. All right, let's do it with respect to y first. So integrand is x, that's f given here, and we're going to do dy dx, right? So the region we're looking at is, maybe I should sketch the region. The region is going to be a quarter disk. So here we're going to have x-axis here and y-axis here. Right, so we're talking about this, the base here. Base, we're looking at this bottom region here, right? So if you sketch that, it's going to look like this. So it's a quarter disk, so it's going to look something like that. And the radius is 4, so this is 4 right there, and this is going to be 4 there. And the region is here, so this is the base region, right? And what we want to do is first we're going to fix the x value. So fix the x value here, right? Then you can see that at this point is y is equal to 0. And they go all the way up to this circle. So it's going to be a y equals square root of 16 minus x squared. So y is going to go from 0 to square root of 16 minus x squared, right? Then to swipe the entire quarter disk, you can see that we're going to start from here is the x equals 0, and then you increase the x value then all the way to, right, the last point would be x equals 4, right? So x is going to go from 0 to 4, right? So that's one order, right? Let's do the other order. So you have a double integral, right? Same integrand, but this time we're going to do with respect to x first, right? We pretty much do the same thing, except that we're going to fix the y value. So I'm going to probably use, let's see, maybe use red, let's see. I'm going to use green here. All right, fix the y value, right? So you can see that x equals 0 is the starting point, and then it's going to end at the circle here. Right, I have to rewrite the equation of the circle. So equation of the circle can be rewritten as, right, square both sides. You have y squared is equal to 16 minus x squared. And switch x squared and y squared, you get x squared equals 16 minus y squared. And then take the square root of both sides. So you have x equals plus or minus square root of 16 minus y squared. Right? In this case, this one is the positive one. So you have y equals square root of 16 minus y squared. Right? So y is going to go, x is going to go from 0 to square root of 16 minus y squared. Right? Then y value is starting from at the y equals 0 all the way to y equals 4. Right? So it's going to go from 0 to 4. Right? We can do either one. First one might require substitution. Second one is probably easier, so I'm going to work on the second one. All right, so I'm going to leave the integral from 0 to 4 alone. And antiderivative of x is x squared over 2. And it's going from 0 to square root of 16 minus y squared. And we're going to do with respect to y later. All right, plug it in. You're going to get, let's see, x squared. So this guy's square root is gone. So it's 16 minus y squared over 2, right? And then you have plug in 0 is still 0, so 0 to 4 dy, right? So this is going to be equal to, right? So you have a 16 over 2 is 8. Antiderivative 8 is 8y, right? Minus y squared over 2. Antiderivative is add 1 to the power, divide by 3. But the 2 was already there, so it's over 6. And then you are going from 0 to 4, right? Alright, plug in 4, that's 4 times 8 is 32, minus, right, 4 cubed is 64 over 6, right, minus plug in 0, it's all 0, right, so let's see, 64 is an even number, so divide by 2 is 32, then it's over 3, so taking a common denominator, so you have a 3 on the bottom, it's a 96 minus 32. So that will be 64 over 3. Right? So the volume is 64 over 3. So let's type it in. 64 over 3. Right? Let's check the answer. Submit for testing. Alright, I came back. Actually, my answer was wrong. Alright, and I believe I did everything correctly, unless I misinterpret something. Alright, only thing I can think of would be since there is actually another region. I didn't think that they would talk about it. But since, remember, if you sketch the y equals square root of 16 minus x squared, it would actually have, there's another a solid which has exactly the same volume as the one we found. And then it's actually below the xy plane. So if they're talking about that, so it's going to look kind of like this. So it's going to go over here and go like that, and that's going to look like, probably look something like that. So there's going to be a symmetric shape on the back side there, and below the x-axis, below the xy plane, which is going to have exactly the same volume of 64 over 3. So maybe they're looking for both of them. So we have to double this volume. All right, let's see if that's what they're looking for. All right, so let's see, 128. So since I doubled it, all right, so let's check the answer. All right, submit for testing. All right, it came back, and looks like we got this one correctly. All right, so I guess the system was looking for the other one too. So we have basically this same two of the same solid kind of put together, because you have a symmetric image on the other side. All right, that's it. I hope that this was clear.